How's it going, everybody? In this video, we're going to take a look at our next EIGRP topic, which is going to be summarization. This is a area that I often see people that are transitioning from CCNA to CCNP, and even a fair amount of CCNPs going to the CCIA level struggle with this capability. The reason I call it out is I was one of them. I understand it now pretty well. So what we're going to do first and foremost when it comes to summarization is we have to understand the concept of most bits in common, so we can figure out what we can summarize, what we can't summarize, and then once we understand those details, then we can take a look at actually getting the summarization in play. So let me go ahead and jump out of the way, and we're going to take a look at a little bit of binary math real quick, so that we're all on the same page in terms of what we need to have in play. So on router 5, I created 10/24 loopbacks. These loopbacks are going to basically represent LAN segments that are going to get advertised, well, I should say they're already advertised, into EIGRP. They start off on, actually it's not 10, it's 9. So I've created loopback 1 through 10, and I started them with the IP address of 172.16.1.0/24, then 2, 3, 4, ... to 10. Fairly straightforward stuff. What this allows me to do is it allows me to summarize /24, /23, /22, and get everything laid out so we can understand the difference between being able to completely cover an environment and having potential black holes and things like that. So let's take a look at how this actually dials in. So when we look at a /24, obviously if you do a /24, that's going to equal to be 1/24, right? I think everybody can agree on that. What does this /23 equal to? And how many /24s make up 1/23? Well, that's 2, right? 2 /24s. What does a /22 incorporate? Well, if you move the bit back 1, you're going to be going to the 4, right? So it's going to be 4 /24s. If I go to /21, what does this equal to? Well, if I move the bit placement 1 further back, that's going to be 8 /24s. /20 is going to be what? I move that bit 1 more to the left, that's going to be 16 /24s. Now, the way that this is going to tally out in the third octet, so we're going to be basically doing Class B summarization, is we need to basically take the /24s that we have here, and we need to figure out, based off of these right here, what we can do in terms of summarization. So, but how do you figure out what you can summarize and what you can't summarize? The way you figure that out is you take the third octet, you take this and you break it into binary. So we'll take 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and we'll figure out the binary equivalents. So up here we'll do the 128, 64, 32, 16, 8, 4, 2, and the 1. Obviously, this one here will be just the 1 is turned on. All of these will be 0 across the board. Okay, 2, same thing. We turn the 1 on here, a 0 here. We do all 0s up here. For the interest of time, I'm just doing it this way. A 3 will be a 1 and a 1. There will be 0s across the board to here. 4 will be a 1, 0, 0. It'll be 0s all the way to here. A 5 is going to be a 4 and a 1 turned on, and a 0 here, a 0 here, across the board. A 6 is going to be a 4 and a 2 turned on, and a 0 here, a 0 here, and we're going to do that across the board here. A 7 is going to be a 4, a 2, and a 1 turned on, a 0 in the 8, and then all the way back this direction. An 8 is obviously going to be turned on here, but off here, and here, and here. And then 16, a 0 there. Bring that all the way across. 9 is going to be a 1, 0, 0, 1, a 0 and 16, bring that back. And then a 10 is going to be a 8 and a 2, zeros in the 4 and the 2 column, or sorry, 4 and the 1 column, 0 and 16, and then zeros all the way back. So anything with a line, these are all zeros, right? Makes it easy just to type them out that way. Now, what we essentially have in this particular case is we need to figure out the most bits in common. So let me go ahead and highlight the areas that have the most bits in common. So right here, right here, and right here. If I am going to summarize anything, I'm going to summarize them. I can summarize 0, 1, 2, and 3 will be summarizable. I can summarize 4, 5, 6, 7, and 8, right? But I can't do them individually. So I can't do this, right? This won't work. These two get encompassed into one summarization route. Bring this down just a little bit further like that. So this would be a, so if I do, actually let me bring this back just one little bit. If I 0, this can get summarized, this is a /23, okay? If I summarize 0 through 3, this becomes, let me actually change that up just a little bit. If I do this, this is a /22, okay, because it's 4 /24s, which is what we saw right here. If I want to take into consideration 7, or do 0 through 7, which is going to be 8, that's going to take all of these guys right to here, and that's going to be a /21. Okay? Now if I take these guys down to here, I have to come all the way down from, I had to do 11, I had to do 12, 13, let's just do, and then do ... I can do 15. That will give me a /20. So you have 23, 22, 21, and 20. The further, the more subnets that you try to summarize in a single advertisement, the more bits you have to have in common, and the more subnets you're going to incorporate. So if I was to go and do a /21, I could take the first, this range right here, back that up just a little bit. I can take this range right here, and this would be one, this would be a /21, right? /21 would be incorporated in the first 7 routes. Not, actually, let me back that up just a little bit. If I put a 0 at the top here, and I go this to here, this right here is a /21. If I wanted to take 0 through 15 and incorporate that all together, this, all 16 routes, is a /20. So that would mean that right now, currently on the router, I have 10 subnets. Effectively, there's 9 of them. So, but I can't remove a single /24 from a range. So I can't take whatever the third subnet would be, or the 8th subnet. I can't, well, that's a bad example. I can't take the 7th /24 out and just advertise those routes. I can't be selective by removing a prefix if I don't want it to be there. It's either I summarize the entire subnet, the /21, or I have to get more specific and I advertise smaller groups, like a /23 or a /22. By doing this, this gives me greater scalability, greater control. So can you take and advertise /23, or for more specifics, if I'm doing a /21 with 7 subnets, can I take 0 through 7 and do a /21 and then follow that up by do 8, 9, and 10? Can I do a /23 and then 1 /24? So I get 0 through 7. I'm sorry, 0 through 7. Then I get, I can do 8 and 9. 8 through 9, and then advertise 10 for it, and these being the third octet, so this would be 172.16.0 through 7.0/24. This would be 172.16.8 through 9.0/24. And this would be 172.16.10.0/24. I can 100% do that and pull that off. That's a 100% acceptable way of summarizing what we have advertised. What that means, I'm doing 3 prefix advertisements. I'm not going to do this, but you could if you wanted to. I could have 3 different summary ranges to advertise. Why would I do that? Why would I go through the trouble of doing all that subnetting and all that summarization if I'll have to advertise that many prefixes? Because I don't want to black hole any traffic. What do I mean by black hole? If I was to advertise a /20, for example, which would encompass all 10 prefixes that I have, but it would also advertise 11, 12, 13, 14, and 15. I don't have these subnets configured or advertised, which means that if something downstream of me is learning a /16, a /20 from me, it's going to assume that 0, let me draw this down here, 0 through 15 are reachable. And that's the big thing that a lot of people miss, is they'll advertise one big prefix, like /20, but then the latter half, 11 through 15, no connectivity. The traffic is black holed. So there are cases where you have to get more specific, and knowing how to figure out the most bits in common. This is the easiest way I could ever draw it out. As a matter of fact, when I was learning how summarization worked, this is how it was explained to me, and it's made a whole ton of sense, because you're taking advantage of the binary you already understand. And the more bits you go from left or from right to left, so the further you go this direction, the more bits are going to be in common, the more you're going to be able to summarize. But that also means you must be actively propagating those routes. Because if you don't advertise these subnets right here, you're going to be basically propagating to another set of routers that you do have them, but when they get to you, they're not going to be there. Now, EIGRP, I'm going to go ahead and clear the screen real quick. EIGRP has a very unique way of handling this. It's not specific to EIGRP, it's an IGP process where if you create a summary, let's say we create the 172.16.0.0/21. So the 21, in this case here, just remember that 24 is 1/24. Let me bring that over just a little bit further. 1/24, right? 23 is 2/24. And 22 is 4/24. And 21 is 8/24. So if we advertise 8/24s, what's going to end up happening is we're going to advertise the individual /24. So we'll advertise 1, 2, 3, 10/24. So we'll have 9/24s advertised in addition to the 172.16.0.0/21 in the IGP table. So EIGRP will propagate it. We'll see this route on the router that's doing it. We'll inject a null 0 route for it. Now, essentially what the null 0 route is going to basically come in and do is say, in the event that I don't have a more specific, if the most specific route is the null route, there's nothing more specific for it, then I'm going to drop the traffic. Essentially what's going to end up happening is if I come in, the traffic comes in on the router, and if I come in and this /21 is actually advertising, I have enough routes available to where a /21 would work, but if I advertise a /20, that's going to be 16 /24s. If I do that, then remember 11, 12, 13, 14, and 15 won't be reachable. right? They'll be black holed. Because they'll be black holed, what we will have to take into consideration is that the null zero route will say, if I don't have a 172.16. Say 13.0/24, which this would be a longer match than a 172.16.0.0/20. This is a shorter match. If this route is not in the table, therefore this guy becomes the longest match. Therefore, 13, 11, 12, 14, and 15, they black hole it. Because the null route is going to kick in and say, drop the traffic. That is why having more specific summary routes might be necessary for you to accomplish the goal that you're trying to accomplish. And that is really the driving factor here when it comes to understanding how summarization works. As long as you understand that, you'll be in a really, really good shape to understand the complexities of summarization. But the whole goal here is for me to explain it so that you understand it. That's basically how that comes into play. So there's a couple different ways that we can go ahead and do this. The first way we're going to do this is on iOS 6. I'm going to go ahead and pull this up. And if we look at iOS 6, because this is a regular EIGRP enabled router, so it's running classic mode. If we do a show IP route EIGRP, we're going to be receiving the 172.16 networks, right? We got 1 through 10, right? They've been sitting there for a while. Now, if I want to advertise those down to XR3, for example, I can go to global config, I can type in interface gig 0/0 and type in IP summary address for EIGRP 100, and now I need to specify the summary length itself. So I'm going to summarize these routes right here, 1, 2, and 3. Okay, so I'll type in 172.16.0.0 slash, I need to do a 22. Now I can be more specific and leak additional prefixes out if I want to, but I'm going to do that. That's going to cause a resync of the connection to XR3. So I'm going to do that, and now I'm also going to do show IP route EIGRP. When we look in the routing table, we're going to see this /22 advertised, and it's going to have a null zero route. What that's going to do is I'm going to take the null zero route and I'm going to have it set up right here on iOS 6. So iOS 6 is the originator of the summary. He is propagating that out this way. XR3 will get a 172.16.0.0/22 summary route in addition to all of these routes right here. These will all be advertised as well. When I get that route, if these prefixes right here will actually, so these three right here will actually fall under this guy right here, and what will end up happening is if for some reason this prefix goes away, let's say 172.16.2 goes bye-bye, in the event that traffic comes back in for 172.16.2.0 say this guy dies, then the null route will be the longest match and the traffic will get dropped as it comes back into router 6. So we're going to go ahead and actually clear the screen and do a little test. So let me go over to XR3. We're going to go ahead and log in real quick. We'll do a show route EIGRP. And we're going to see that not only do we get the summary prefix to come across, but we also get the /24s to come across as well. So if I go to router 5, I do a show IP interface brief, and I go to global config and type interface loopback 2 and shut it down. That'll shut down the interface. I go back to XR3 and I hit the up arrow, we'll see the 172.16 route is, actually let me unshut that real quick. Let me type in no shut to prove that it'll actually work. We go back to XR3 and let me ping to 172.16.2.5. Okay, and let me do a trace to 172.16.2.5 numerically. Okay, I get there via, I'm taking this path right here. I'm going XR3 to router 4. So on router 4 side, on XR3, let me go to router EIGRP AS100, address family IPv4, and interface gig 00002. We'll set the delay to be the metric for delay will be, I'll set it really, really high. So it'll be less preferred. So we do show route EIGRP. We should only choose to go traffic out. Apparently that wasn't high enough. Show run interface gig 00002. Show interface, or show EIGRP interface gig 00002. Detail. The delay on that guy is apparently not high enough. 100,000. What is one set to? Delay is that. So I need to go and make that bigger actually. So we're gonna go to router EIGRP AS100. We'll specify address family IPv4, and then interface gig 00002. The metric delay will be this plus an additional 0. That should fix that problem. So show route EIGRP. There it goes. So now if I take that same trace route again, I should go via, I want to go via X, I don't want to go that route. I want to go, there we go. 3.4. Why is it still going? You know what? Interface gig 00002. Shut it down. I want to force traffic to go a specific direction. So we'll do a show route EIGRP. So now we should be forcibly learning it in. Okay, so now it's actually so the routes that I was learning in. Let's make sure that it's coming across. So the summary route is taking over here, which is what we want to see. Now, so what you were seeing before with this stuff right here, where the prefixes were coming in via both paths, these right here are the longer match routes that were coming in from router 4. So it's coming in, so basically to explain what ended up happening. So I basically forced the router's hand. So the /22 is being advertised this way for 172.16. Basically 0 through 3.0/24. And then via this path, all these prefixes are being advertised as /24s. So the longer match would send the traffic this way, where I'm trying to send the traffic this direction. So that's why that was happening. So by shutting down this connection, I'm forcibly sending traffic this way, so only the /22 shows up. But now what I'll be able to do is I'll be able to show the directionality of the traffic. It should go the direction I want it to now. It should go 3 to 6 to via router 6. Now if I go to router 5 and I shut down this interface, give that a couple seconds to propagate, I go back to XR3 and I do a show route EIGRP, that prefix is still there. It doesn't go away. But the reachability, router 6 is like, well, I don't know what to do with it. I have no idea how to reach it. If I try to ping 172.16.2.5, I'm going to get nothing back. And this is where that on router 6, if we go back to here, do show IP route EIGRP, we are no longer receiving, we're still propagating the summary, but we're no longer propagating the 172.16.2 network. That's gone. So now the longest match is the null route, and therefore we are going to drop the traffic because it's going to hit the null and be dropped. So that's basically how that comes into play. So I'm going to go back to XR3, and I'm going to go to interface gig 000002, and I'm going to no shut the interface. And then on iOS 6, we're going to hit the up arrow, and I'm going to pull this command out. So we don't want to propagate that anymore. I'm going to show you how to do it on router 4, which I believe is running show IP EIGRP 100. Show IP protocols. EIGRP in named mode. Cool. So I'm going to go to global config, and if I do show IP route EIGRP, we can see everything's being propagated. I'm going to go back to router 5, and I'm going to no shut that interface. Alright, now that's being advertised. I'm going to go ahead and I'm going to show you on router 4 how you would do it with named mode. So router EIGRP named mode, address family IPv4 autonomous system 100, and then underneath AF interface of gig 0/2, we're going to type in summary address of 172.16.0.0/22. So just the first 3 addresses are going to get summarized, and we're going to hit the enter key, and that's going to cause a resynchronization with XR3. If we do show IP route EIGRP, we can see in the routing table that we are going to be propagating a summary, which is there. I'm going to go to XR3 and do a show route, and I can see the summary coming in. This time it's coming in from gig 002. And then I've got these longer match routes coming in from gig 001. So I could summarize from both directions, and this is one of the common things that you'll see in when we get into DMBPN, how we can affect with multiple tunnels being advertised from different routers, how we can affect how EIGRP is going to be forwarded based off of summarization. We'll take a look at that when we get into DMBPN. But I just wanted to give you an example of how that would come into play in the routing here. So could I advertise the /24s from, or /22s from both sides? I certainly could. So if I wanted to advertise from router 6 as well, let's say I go underneath here and I advertise the /22 from here. Cause the resynchronization. If I go back to XR3 and I do a show route, we will see that the 172.16 /22 comes into play. You'll notice that all these other routes go away. 1, 2, and 3 are now gone. Again, they are suppressed because there is a shorter match that encompasses those and covers the spread, right? So there's no reason to advertise more specific prefixes, and if we don't need to. Now, there are still going to be routes that are going to be received, because if we were to go on to XR3 and do a show EIGRP topology all links, what we're going to see for that is, bring it down here just a little bit, you'll see the /22 right here. We're receiving it from 6 and from 4. So it's coming from router 6 and from router 4. Now, if I wanted to extend this to be potentially learned via other paths, for example, on iOS 4, I could go underneath gig 0/0 and do the same thing. So it's going to cause a I'm going to advertise a summary out from R4 towards XR2. Now I go back to XR3 and I hit the up arrow. We should see, and it might take it a couple seconds for it to propagate, but potentially a third summary route. I don't know if it's actually going to show it here, but yeah, it doesn't look like it's going to trigger here. But if I was to log in here and do a show route EIGRP, we should get the /22 here. If I go to router 1, show IP route EIGRP, and I see the /22 here, and I see that coming in from XR2, I should theoretically send that to XR3, and XR3 should see it. We don't see it coming in from here, from our peering from those routes, because from R1's perspective, we are down. XR3 is technically upstream from that, and that would be a loop. But we are, if we were to look at this, let's see. This should show me everything that I should be getting updates from. Show IP EIGRP neighbors. It might not form a show EIGRP neighbors. That explains it. So let's go show run router EIGRP. I was wondering why that wasn't coming across. Gig 0/0. Apparently, router 1, show IP EIGRP interfaces. Gig 0/0. Oh, I see why. Show IP interface brief. Did I not? That explains it. Interface gig 0/. Did I not enable gig 0/0? Yep. 0. No, shut that interface. That explains it. We should form an EIGRP adjacency, which we do. Now we go back to XR3, and I do that all links command again. It might take it a couple of seconds for it to show up. Show EIGRP neighbors. I do have the adjacency up now, and it might take it some time, but we should see that /22 come in again. Let's see. I want to see all successors. All links. Let me see here. Neighbors on gig 0/0/0/0/0/0 detail. I received prefixes from him. I've received 10 prefixes. Neighbor detail. It won't tell me what I'm learning. But if I look at what I've learned from 6 and what I've learned from 4, oh, excuse me. Prefixes received, yeah, I received 10. So it's suppressing some of the things that it's learned. And the reason why it's suppressing those is, if we look at router 1, for example, we show IP route EIGRP, and we take a look at what's been brought in, we are not going to advertise, because technically router 1 is downstream of XR3. So because XR3 is downstream of, is upstream of R1, there would be no reason why R1 would propagate the route to it. So now if I was to do this instead though, if I was to go to, on XR3, not router 1. If I was to go to global config and What interface am I dealing with? So interface gig 000001 shut and 2 shut. We go ahead and commit that. That'll take down the adjacencies to 6 and to 4, right? We go to global config and logging con debug. It bothers me that I don't get to see this stuff. So we do a show IP interface brief. Those interfaces are down. Now, show EIGRP neighbors. I should only have one connection. Show, I do detail. I'm receiving 25 prefixes now. See, those additional prefixes are coming in. Show EIGRP topology all links. Now I should be receiving that /24, but it's I was always receiving it. Where is it? 172.16. I was always receiving it, but because the fact that I'm receiving it with such a high feasible distance, now it's taking the path that it needs to take. But because the fact that I had an active adjacency here and here and here and here, it's like I was sending the routes this way and sending the routes down this way. Technically, this guy right here is upstream, and this guy, router 6, is upstream of XR3. This guy right here, this connection right here, XR3 is upstream of iOS 1. iOS 1 is downstream of XR3. Because of the way that the dual calculation came into play, think of it like this, where you'd have 5 and 6. Let me draw it this way instead, just so you understand why things aren't showing up the way that they are. If we were to take 5 and 6, 4 and XR3, we take XR2 and 1. This guy right here has the 172.16.1 through 10.0 / prefixes here. 6 is summarizing this way, 5 is summarizing this way, and 4 is summarizing this way. Okay? Now, because he's summarizing these directions, 4 is going to send the summary down to XR3, and XR2 is going to send the summary down to R2. R1 is still going to send the summary this way. It's still going to get received. But because of the fact of the feasible distance here on the routes learned from XR3 are going to be so much higher than what are received from 4 and from 6, that XR3 is going to say, well, don't install them. Don't put them in the routing table in the topology table. It doesn't make any sense, because from a forwarding perspective, this is the core, this is the distribution, and this is access. From a EIGRP topology standpoint, that's how it's viewed, and that's the thing that you need to understand. I'm kind of intentionally overcomplicating it, and just so you guys understand how the flow goes. So even though these prefixes are being sent down this way, brought back around here, and being sent back up here, the routes that need to get advertised are getting advertised, but that /22 stops here. It doesn't get sent up here. That route advertisement doesn't make it that far up. And that's where the summarization piece comes into play. So, but you can see that by taking down this connection and taking down this connection, that this /22 shows up here on XR3. And we can validate that. If we clear the screen as well, we can look in the routing table and we can see the /22, right? It's being brought in. If we do a show route EIGRP, we can clearly see the /22 being learned from router 1. So it's not that it's not getting learned, it's simply getting suppressed because the feasible distance is so high, it doesn't make any sense to put it into the topology table. So let's go ahead and go back to XR3. We'll go back to global config, do show IP interface brief. We'll type in interface gig 0000001, no shut it. We'll go ahead and commit that, bring it back online. That's going to get our EIGRP adjacencies back in play. And we'll do our show EIGRP neighbors. We have our adjacencies back. We do show EIGRP topology all links. We are receiving the /22 in, right? But from gig 1 and gig 2. But look at how much lower the feasible distance is. We are receiving like the 10, 100, or the 102, we're receiving all those, but the routes that are coming from northbound of the network, from 5 and from 6, are they're north or upstream in terms of the way that the topology is laid out, and that's why we're seeing things show up the way that they are. How critical is this for your exam? Not very critical. I don't think so. But it's important to understand how EIGRP calculates those routes. If that's something you've ever struggled with, welcome to the club. But the more time you spend on it, you can understand why it's being propagated. If we were to do a debug, you would see those routes being advertised from router 1, or if we were to do a Wireshark capture, you would see the traffic coming across. Because if we shut down those links between 3 and 4 and 3 and 5, or sorry, 3 and 6, the /22 is still there. It's just got a really, really high feasible distance, which means the topology table is pretty much hiding it, it's suppressing it. The other way you can tell here is with the show EIGRP neighbors detail, you can see that we can see from 6 and from 4 that we're both learning 20 routes. But from router 1, we're only learning 10. And that's a clear indication that XR3 is intentionally suppressing the routes so that we don't get an inconsistent topology table. So as long as you understand that, you're in really good shape. So that's how that goes. Now there's a couple other ways that you can do EIGRP summarization. You can do a default route. You can do that. And if you do a default route, then that will work effectively. So basically the idea of that would be on router 5, if we were to go to global config and router EIGRP named mode, address family IPv4, and then autonomous system 100, underneath interface gig 00000. I'm sorry. And then AF interface is gig 0/0 and do summary address 0.0.0.0/0 and hit the enter key. This is going to advertise a default route. So do show IP route EIGRP. We're going to see a default route in the routing table. Might take it a second for. You know what? There's got to be a default route in the routing table already. So you notice the /22 is getting advertised, but none of the more specific routes. So if I was to remove that command, actually let's do show run section EIGRP. We can see that underneath the interface we have that gig 0/0. We have just that summary that we're advertising, and the 172.16 that's being propagated. If we do show IP route EIGRP, that we are receiving a /22 in from router 4, because that's what it's advertising it. And we are not getting anything more specific. So until I put a default route in play, because right now there isn't one, because I don't need to have a default route in here. The default route would be, I would need an actual static route first to somewhere, and then the default route would trigger. So if I was to do this out of kicks and giggles, let's just do IP route, a default route to 100.5.17.17. So if I do ping 100.5.17.17, so router 17 isn't configured yet apparently. It doesn't matter, but I'll go configure it real quick. IP address here will be 100.5.17.17/24, and we'll type in hostname is iOS 17. We'll do route that, or sorry, do save the config. If we go back to router 5, that should come online. It doesn't need to be reachable, but if I do a show IP route EIGRP, we'll see a default route in the routing table. We can see it right here, and we'll be in good shape. If I do show IP route, we'll actually see a static route, a default here, which is what we want to see, and everything's working out the way that we need to have it there. So that's just a couple of examples of how you can do summarization. So that's pretty much it for EIGRP. We'll be taking a look at some other examples of it in later discussions for doing like MPLS VPN. We will take a look at it with DMVPN, with Flex VPN, and things like that. If you have any questions, please leave a comment in the comment section below, and I will talk to all of you in the next video.